So one thing that we can do is we can use what we know about derivatives to evaluate certain 0 over 0 type limits. So here what we have is we have the limit as x approaches pi over 4 of tan x minus 1 over x minus pi over 4. You can verify actually that since tan of pi over 4 is equal to 1, this in fact is 1 minus 1 over pi over 4 minus pi over 4. So it is in fact a 0 over 0 limit. Um, the way we can evaluate this is to recognize something, that this is looking very, very close to one of our definitions of the derivative, which was that f prime of a is equal to the limit as x approaches a of f of x minus f of a over x minus a. So we're almost there. We just have to observe what is that 1 doing there. Well, since of course tangent of pi over 4 is equal to 1, there's no reason I can't simply replace this 1 with a completely equivalent expression, which is tangent of pi over 4. I want to make that look like a 9. It's tangent of pi over 4. So we can simply observe that this is equal to the limit as x approaches pi over 4 of tan x minus tan of pi over 4 over x minus pi over 4, which means that this should be equal to f prime of a, where this is playing the role of f of x, and this is playing the role of f, and this is playing the role of f. So this is where f of x is equal to tangent of x. Now that's kind of nice because we actually know what the derivative of tangent of x is. So since this derivative is going to be equal to, this limit is going to be equal to the derivative evaluated at a, I can simply observe that f prime of x is equal to secant squared x, and of course the thing that's playing the role of a here is going to be that. Notice that that's where the a appears in this form, along with that's also a, that's also a, so you can see what a is. So what I'm evaluating here is going to be f prime of pi over 4, which is secant squared of pi over 4, which is going to be 1 over cosine squared of pi over 4. That's going to be 1 over root 2 over 2 squared. So cosine of pi over 4 is root 2 over 2. So that's 1 over, that will be 2 over 4, which is 4 over 2, which is actually 2. So there we go. This limit is equal to 2.